Welcome to the second episode on atomic structure. Let's continue our discussion regarding the strategy NEET of this year, which contains most likely questions from this chapter of atomic structure. Let's begin. First question. The energies E1 and E2 of two radiations are 25 electron volt and 50 electron volt respectively. The relation between their wavelengths, that is lambda 1 and lambda 2, will be. Let's say the energies of E1 and E2 are there, having two radiations of 25 electron volt and one more is 50 electron volt. E1 is 25 electron volt and E2 is 50 electron volt. Now the relation between their wavelengths, lambda 1 and lambda 2, lambda 1 for E1, lambda 2 for E2 will be, is it lambda 1 is equal to 2 lambda 2, or option B, lambda 1 is equal to 4 times lambda 2, or lambda 1 is equal to half the value of lambda 2, or is it lambda 1 directly equal to lambda 2? So let's see which one is the answer. Answer is option A, lambda 1 is equal to 2 times lambda 2. Let's see how to solve this numerical. Now E1 as we know is 25 electron volt and E2 is 50 electron volt respectively. So let's calculate what is the value of E1. When E1 or E will be equal to, what is the formula to be used when you do not know the frequency? So when frequency is not known, instead of E is equal to h nu, you are going to replace nu by C by lambda. So this is for the first case. So E1 is equal to hc by lambda 1 and E2 is equal to hc by lambda 2, or E1 by E2 is equal to lambda 2 by lambda 1. So let's put that value. 25 for E1 and 50 for E2 will be equal to lambda 2 by lambda 1, that is lambda 1 is equal to 2 times the value of lambda 2. So that's such a simple numerical, but when you read, so you might get confused. So how to do this? So here is a simple method to solve this. Hope you understood this. Now let's proceed with the option, that is lambda 1 is equal to 2 times lambda 2, which is option A. Now let's take up the second question. The energy absorbed by each molecule A2 of a substance is 4.4 into 10 to the power minus 19 joule, and bond energy per molecule is 4.0 into 10 to the power minus 19 joule. The kinetic energy of the molecule per atom will be. So what's given? Let's take a second to understand this. The energy absorbed by each molecule A2 of a substance is 4.4 into 10 to the power minus 19 joule. That's the amount of energy absorbed. And bond energy per molecule is 4.0 into 10 to the power minus 19 joule. What will be the kinetic energy of the molecule per atom? This is the question. This is a molecule and we need to calculate it for one atom. So let's look into the options given. Option A, 2.0 into 10 to the power minus 20 joule. Option B, 2.2 into 10 to the power minus 19 joule. Option C, 2.0 into 10 to the power minus 19 joule. Option D, 4.0 into 10 to the power minus 20 joule. So let's see which one is the correct answer. Option A, 2.0 into 10 to the power minus 20 joule is the correct answer. Let's see how to do the calculation for this. Kinetic energy of a molecule is given by the formula energy absorbed by a molecule minus bond energy per molecule. So this is a simple formula you should remember. I repeat. So how to calculate the kinetic energy of a molecule? This will be given by energy absorbed by the molecule minus bond energy per molecule. So what is the energy absorbed by the molecule? It is given to us as 4.4 into 10 to the power minus 19 joule minus bond energy per molecule. That will be 4.0 into 10 to the power minus 19 joule. So when you take the difference, easy to calculate, it will be 0.4 into 10 to the power minus 19 joule. You know that a molecule, they've already said it is A2. That means one molecule is containing two atoms in it. Therefore, for one atom will be kinetic energy per atom will be whatever the value you got divided by 2. Say supposing if this question would have been for sulfur, it would be SE8. So you should have divided it by 8, or if it is for phosphorus, you should have divided it by 4. In this case, the formula is given as A2. That means it's a diatomic molecule. Therefore, you are going to divide whatever the energy, kinetic energy you got by 2 to calculate it for one atom. So the value will be 0.4 into 10 to the power minus 19 by 2. As simple as that, which is 2.0 into 10 to the power minus 20 joule, which is our option A. So this is the simple method of solving this numericals. Just go through all of the parts in this chapter of atomic structure, wherein I am covering all the most likely questions, the type questions which are likely to come for this year NEET examination. I wish you all the best.